Today's problem from matrix algebra, and the problem is A is a square matrix of order n. Okay, that is A is a matrix which is n cross n. Okay, and it is said that n, this is the maximum number of distinct entries of A if A is triangular matrix, right? M, which is the maximum number of distinct entries if A is diagonal matrix, and P is the minimum number of zeros if A is a triangular matrix. Then if L plus 5, this is equal to P plus 2M, find the order of the matrix. That is, we have to find the value of n using this relation. If we consider a matrix like that, this is n cross n matrix. That is, this matrix has n rows and n columns. And we start from L. This is said to be triangular matrix. We know that triangular matrix are of two types. It may be upper triangular or it may be lower triangular. If we consider upper triangular matrix, then this is the principal diagonal we know, and all these entries are maybe non-zero, and the entries below the principal diagonal must be zeros for upper triangular matrix. So for the upper triangular matrix, the maximum number of distinct entries are given by, for the first row there be n element, for the second row there be n minus 1 element, and for the third row there be n minus 2 element, and so on. For the last row there is only one element on the principal diagonal position, this is 1. So we get the maximum value of L. This is given by 1 plus 2 plus 3 plus 2n. We taken summation from 1, 2 and to n, and which is given by n into n plus 1 by 2. Okay, so we get the value of L first. Now the maximum number of distinct entries of A if A is diagonal. We know that if this diagonal matrix, there are only n entries are distinct and others are 0. Okay, so we get M, this is equal to n because distinct element are this, and for P we write here P, this is given by minimum number of zeros if A is triangular matrix. If we let that it is upper triangular, then this all element must be zeros. So to count these zeros, we taken from here. If we consider the last row first, then we get n minus 1 zeros, and then n minus 2 zeros, and then we get 1 zeros here, and we get 0 zeros in the first row. Okay, for making a triangular matrix. Then we get P, this is equal to 1 plus 2 plus 2 n minus 1, and we get this value is n into n minus 1 by 2. Now putting these three values here, we get the result as n into n plus 1 by 2 plus 5, this is given by P. P means this n into n minus 1 by 2 plus this is given by 2m. So this is 2n because m equal to n, right? And getting the result as we get by taking 2 as the LCM and taking common here n, we get n minus 1 plus 4, right? So n into n plus 3 by 2, and we get this minus this n into n plus 3 by 2 minus n into n plus 1 by 2. This is given by 5. And n by 2 we take common from these two relations and getting the result n plus 3 minus n minus 1, this is equal to 5. So we get n cancel out and getting the value n by 2 into this is 2, this is equal to 5. So we get n, this is equal to 5. Okay, so we get n equal to 5. That is the order of the matrix must be n, this is equal to 5. This is our final answer. Okay, very easy problem, but we use here the concept of triangular matrix, diagonal matrix and the order of matrix. Right. Thank you for watching.